Hello, welcome to the math vlog. We have a system of two equations which we need to find an answer for. We have two equations and two unknowns, two unknown variables. I'm using the substitution method, meaning I need to isolate one variable. It can be either x or y, no matter. I can use the first equation or the second equation. That doesn't matter either. I have to make the decisions. I look at my equations and my variables and see which will be easiest to isolate. Is it going to be easy? No, but at least easier. I'm looking at number 2 here. We have negative 4x plus 2y equals 3. I think the y variable should be easy to isolate. We'll see what happens. I'll isolate y first, and we'll go from there. Once I isolate y, I'll substitute the expression where y is in the first equation. I'm going to pause here. In several vlogs we talk about solving equations, working on equations. We need to keep our left side and our right side variable. That's left and right of the equal sign. Now my goal is to solve for y, and everything else around the y I want to get rid of. We're working in the concept of opposite. Like here I have negative 4x, so I'm going to add 4x to get rid of it. And then I need to work on the other side and add 4x there too. Now I have 2y equals 4x plus 3. Now the y still isn't by itself. It's 2 times y. I'd like to have y, just the y hanging out there. I want 2 to become a 1. So if we divide 2 by 2, it will be 1y. Another way to think of that is 2 times y. We're going to work backwards to y, so divide by 2. But we divide each term by 2 as well. 2y divided by 2, 4x divided by 2, and 3 divided by 2. Now, before we all freak out over the fractions, it's not terrible. I knew it was going to come up. It's there. I have y equals 2x plus 3 divided by 2, or 3 halves. This is from our second equation, so I can't substitute it back into the second equation. I have to substitute into the first equation. We'll replace the y in the first equation with this 2x plus 3 halves, and I'll have one equation with one variable, and then I can solve for x. Okay, now you can see I've substituted the expression 2x plus 3 halves for y because they're equivalent, so I can do that. They're interchangeable. Y and the expression 2x plus 3 halves in this equation. Okay, so we use this fact to make the substitution. Now we have negative 6 plus 3 times the quantity 2x plus 3 halves. Now my y variable is no longer present, and I have the x variable only. Now I can solve for x. This is called it's a special system. It's called an inconsistent system. Means the two lines we have, if we were to graph them, they would never touch and never cross. They're parallel. As we can see here, we have 4.5 equals 3, which is false. It'll be false forever, which means that these systems, these two equations, can never share the same x and y pair. No matter what we put in, it'll always be false. So we say the system has no solution. So, as you can see, the x term disappeared. So we have 4.5 equals 3, which is false. That means that these two lines will never touch and will be parallel, and are parallel forever. So there's no solution for this system. Line 1 is parallel to line number 2.